Hello, everyone. Thank you so much for taking time to join us today. I'm Stacy Cayley. I'm the Network Relationship Manager for Good Systems, the Interdisciplinary Ethical AI Grand Challenge here at UT Austin. And we're excited to kick off our first speaker series event of the season. And we're really happy to have Ben Brooks of Stability AI here with us today. The Good Systems Speaker Series aims to bring together diverse perspectives in ethical AI to explore important questions about how we can work together across sectors to build ethical, responsible, and trustworthy human AI systems. Our host today is Dr. Dave Niyogi. He is a professor in the Jackson School of Geosciences and the Cockrell School of Engineering here at UT Austin. And he is a lead researcher on our Good System for Smart Cities project. And Dr. Niyogi, I will turn it over to you.
Thank you, and welcome everyone, and a very warm Texas welcome to Ben. Ben Brooks. Dr. Ben Brooks, he has been a extremely prolific policymaker interface, I would say, for the AI community. And he was going to talk more about what he has been doing. But I'd been seeing some of the work he has been doing with regards to the testimony, for instance, to the House of Lords, which was recently released, and the testimony to the US Congress, and worked with over 25 countries in trying to create a link with regards to how do you bring in AI policy that is both going to foster safety as well as bring the innovation, something along the lines of what Good System has been championing with the community here. Ben Brooks has also been involved with some of the things that we probably have been using or want to use more, things like Uber and Coinbase, if you're into the crypto market. Those are some of the areas that he has been involved quite much, and there's several more of them. He will be also talking more about, I think, the work he has been doing right from Texas to Tel Aviv to Lagos to London to Brussels to Burma and across the globe. And while right now he's based, I believe, in the West Coast, he also comes from Sydney. And we were just talking about, the beautiful cold winters there right now. So without much ado, I would ask Ben Brooks to talk about his work. But I also wanted to give a context to the smart city work that we have been doing here under Good Systems, which lays the foundation for some of the issues that are of interest here in the context of how we are creating an interface for urban digital twins, how we are also working with the city of Austin and other cities in creating what is the first ever city climate collab. So almost everything that we have is at a global scale or at a regional scale, but very locally, how cities using climate information, weather information, that is something we have created for urban digital twins and fire and other applications. In all of this, there is this whole issue about people perspective, and then there's the issue about the data and trying to put them together. We have been trying to develop this analysis. So we look forward to your talk. And of course, welcome to all the participants to this meeting. And I will let Ben decide whether he would like to be interrupted when he's speaking or if you'd like to have questions at the end. But Ben, over to you.
Yeah, wonderful. Thanks, Dave, and good to meet you all. Interesting times in AI, as I'm sure you're aware. Thanks for flashing that up, Alice, and you can probably flick across to the next slide. As Dev said, my background is regulatory policy. So I've worked with companies like Uber, Google's drone delivery company, Coinbase, and others to think about, how to sort of fit a square peg in a round hole. How do we take a novel, disruptive technology and integrate it into an existing legal system, a legal system that in many cases is hundreds of years old. This was Stable Diffusion's attempt to summarize my background in an image somewhat successfully. Behind the Capitol building there, that's meant to be a giant Bitcoin symbol rising as the sun, I believe. But look, I mean, the idea is, you know, how can we help authorities in particular identify a path towards sort of swift and sensible reform if the case for reform is made out, and if there's a gap in the law, and if there's some kind of harm and product policy, corporate policy isn't keeping up with public expectations. As Deb said, you know, I've got very sort of global lens on these issues. You know, spend a lot of time working with Washington and Brussels at the moment, but we're very interested as well in, you know, what does tech reform, and in this case, AI reform and AI governance look like in the long tail of smaller states globally as well, for reasons that I'll get to later. But today I'm proud to be representing Stability AI and our huge community of developers. We represent a fairly unique perspective within the generative AI industry, if you can call it that. We are a leading multimodal developer of open models. I'll explain a little bit more what that means in a minute. But it means that, you know, we think a lot about how to make this technology more accessible. How can we responsibly deploy it in a way that provides sort of maximum opportunities for developers and researchers to participate, not just on the sort of the edge of the tech stack, but right down in the AI models themselves. So what I thought I'd do today is sort of talk about three things. One is giving you a sense for the kind of research and development activity that we're conducting across the generative AI domain, and how we should think about the use of these tools in the context of existing workflows. And secondly, want to discuss the importance of open models to the future digital economy and open innovation, particularly as it relates to transparency and competition. And then finally, want to sort of think through what all of this means for policymakers, the implications of not just generative AI for policy, but specifically of open models and open source development. So I think I'll speak, you know, maybe for 20, 30 minutes, and then would love to have a kind of robust Q&A. So if folks have a think about burning issues, happy to address those towards the end. And if there's something super burning that comes up during the talk, feel free to raise a hand or jump in. Very happy to keep this free flowing. Next slide, Alison. So we are a global tech company. We're about a year old, and our goal is to unlock humanity's potential by making foundational AI technology accessible to all. To that end, we develop AI models across a range of modalities. So in effect, these are just software programs that take an input or an instruction from a user and can help to produce complex new content. Our flagship model, as many of you may be aware, is Stable Diffusion, which is a powerful latent diffusion model that can take a text instruction or prompt, as well as other inputs from a user, and help to generate or transform an image. Stable Diffusion began as an academic project, an open source academic project in Germany. Stability AI funded the compute required to train and develop the model. And we took over the exclusive development of that model late last year. You can see on the right there just an example, a relatively simple example of a photograph of an astronaut riding a pink horse in space. And these models are able to interpret the text instruction, convert that into an embedding, a kind of machine readable format, and then draw together an understanding of fundamental structures and features to help assemble and generate that image as a new work from the ground up. We're also working in the same domain on video models as well. And we're happy at this point that I think 4 of the 5 original latent diffusion researchers now work with us at Stability AI. So continuing to push the bounds on what's possible in image and video. Next slide. We're also heavily engaged in language model development. So we have a family of language models that we've developed to support research into safety and accessibility in the language domain. To give you some idea, our largest fine-tuned model, Stable Beluga, for a period of time over the summer was the highest performing open or open source language model available anywhere in the world. we've released a series of small base models. Most recently, just a few days ago, last week, we released a 3 billion parameter language model, and it was a very, very small language model. That is the highest performing 3 billion parameter language model openly available, and it outperforms many larger language models as well. And we also have the most high performing open Japanese model. So we're heavily invested in making sure that underrepresented languages and communities have state-of-the-art open resources at the foundation model layer. You can see on the left here, this is an example of stable beluga. And again, just very exciting that now, over the past few months, you've got and we'll talk about this in a minute, but a whole series of powerful open or open source based models enabling developers and researchers around the world to do really exciting, really interesting things, and moving the envelope on safety and performance. Next slide. And finally, we have developed a series of audio models. We released the first of our audio models just a couple of weeks ago. It was very well received by the creative community. Again, it's a latent diffusion architecture. And so, it takes a text instruction or series of instructions from a user and can help to synthesize and generate a new soundtrack. It overcomes a number of, major limitations in audio generation. Typically, audio generation is limited to very short soundtracks or sound clips. This can generate up to 90 seconds of a soundtrack in high quality 44,000 hertz. So very exciting. It's been very well received by the creative community. Alison, I'm not sure if you're able to play that clip just by clicking on it, but that gives you a sense. I can't hear anything. You might not have audio shared. In any case, folks can go and play around and have a look at this tool online on our website and elsewhere. And we're planning to release an open version of the audio model in the near future. Next slide. So what really sets us apart is that where possible and with appropriate safeguards, we release our models openly, which means we make available not just the code to run inference on the model, in other words, to run the model, but also make available the billions of distinctive settings or weights that determine the model's performance. What that means in practice is that if you're an independent researcher, developer, small business, you can come along, you can take those weights and that code, you can use it, you can integrate it, you can adapt it to build your own specialized models or to build your own AI applications or start your own AI venture. To give you some sense of the scale here, there are some third-party estimates that suggest that perhaps 80% or 12 or 15 billion AI images over the past 18 months have been produced with Stable Diffusion, our open image model. We've seen over 9 million downloads of our open image models on repositories like Hugging Face. So these aren't people using the model to run inference and make a picture. These are people who are actually downloading the inference code and the weights. We've seen over 2 million downloads of our open language models, again, ranging from the small base models, the large fine-tuned models, to some of the more bespoke models like our software developer models or our Japanese models. And we have almost 300,000 active community members on Discord. So open, and that's just us. We are one player in the open and open source space, but it gives you some sense for the scale of what we're talking about. And as we'll talk about later, that has certain implications for policymakers. Next click, Alison. From our perspective, it's important to think about generative AI as a component in the tech stack, and it's a component that will become critical infrastructure or essential technology. I mean, it will be the backbone of how we access essential services through tools like chatbots. It will totally reshape how we search and access information online through search engines. And it will support knowledge management and decision-making and analysis in some of our most important public and private institutions. So as much as a lot of the media kind of focuses on ChatGPT and push a button, get an image, these models will power some very serious capabilities right across the economy. In that context, releasing these models openly plays a really important role in helping to keep that AI ecosystem diverse and transparent and competitive. From a transparency perspective, if we release the weights openly and if we release the data sets openly, researchers and authorities can look under the hood to verify the performance of the model, inspect it for vulnerabilities or risks, start to develop new techniques for interpretability, and help to develop new mitigations for emerging behaviors or emerging capabilities. That's not necessarily possible in a closed source environment. A closed source environment, the model is in a black box, and risk management and risk assurance depends a lot in trust in the developer. And that's not necessarily going to be sustainable as we implement this across the economy in increasingly more sensitive environments. A second reason is security. I think a lot of folks tend to forget just how important Linux and Android are to our digital economy. You can find Linux in US Navy submarines. You can find it on SpaceX rockets. You find it in a majority of, Android in a majority of smartphones globally. And we think the same will be true of AI models. If you're a sensitive institution or you're a public sector agency and you are building AI capabilities, you need to build those capabilities in-house. You don't want to expose your data to a third party. You don't want to be dependent on a third party for your AI capabilities. And you don't want to give up control of the weights that determine your AI model's performance. And so we think there's going to be a huge enterprise and public sector demand for open and open source models because of that security. You can train it in-house and on-prem. You don't expose that data. You don't give up control of the model. Another reason is fair access to essential technology. We want creators, developers, small businesses to be able to participate in all of this activity, all of this development without relying on someone else's API. Ultimately, that has huge competitive implications, lowers barriers to entry, and ultimately that means we see greater competition, not just in downstream AI applications and AI services, but also greater competition in AI model development as well. We've seen for the past 20 years what happens when the digital economy depends on one search engine, 2 social media platforms, 3 cloud compute providers. We're at serious risk of repeating some of those mistakes again in AI unless we have a vibrant, open and open source ecosystem. And the final piece is that if you have open models, the community can better inspect those models and correct for certain behavioral biases that are very problematic, whether that's language, demographics, political values, or other more subtle kinds of biases. And it's important that folks have access to the weights and access to the documentation to enable them to do that. Next slide. What's really interesting from our perspective is if you look over the past 9 months, 12 months, across governments in particular, there's been this kind of fixation on big models from big brands. And what that is doing is it's overlooking the role that grassroots innovation in open models plays in the AI ecosystem. And that grassroots innovation is ultimately helping to make AI not just safer, but also more useful and more accessible. There are 3 kind of really important trends here that I think is worth pointing out. The first is that you have these open source models. You don't just have proprietary models. Training a base model, a raw model from scratch requires significant resources. OpenAI, I think, said that GPT-4 costs $100 million to train. That is not available to everyday researchers, developers, small businesses. And so we want to make sure that they have access to base raw AI models that essentially just know how to read or write or draw, and they can then experiment and adapt and innovate on those models and get a foot in the door and aren't shut out by the cost of compute or the cost of research. Next click. The second trend is that you have this kind of Cambrian explosion off the back of those open base models in specialized models that have been adapted for particular purposes. When I say Cambrian explosion, we're talking thousands, hundreds of thousands of these models that have been built up on the basis of an open or open source base capability-based model. Now, developers and researchers can fine-tune or adapt these models using a range of techniques that don't require $100 million in compute and research. We think about techniques like fine-tuning or instruct tuning, or we think about the way that you can use human feedback or AI feedback to steer the behavior of a model, these are much more accessible to everyday participants, and they can yield drastic changes in the performance of these models. As I say, Stable Beluga, our fine-tuned model, the base model for that is Llama 2, which was an open model released by Meta. When they released that model, I think in a matter of 3 days or thereabouts, we had a couple of our researchers fine-tune that model, deliver significant improvements in performance, and ultimately that model for a period of time was the highest performing open model anywhere in the world. Next click. The third trend is we're seeing this wave of smaller models, not just bigger models. We expect that smaller models will be more efficient, and ultimately that will help to make AI more accessible to businesses, developers right across the economy, and support a range of everyday applications. Large models require huge computational resources to train, and often require huge computational resources to run them as well. With these smaller models, you're talking about models that are 25, 50, hundreds of times smaller than the kind of big models from big brands that we think about, like GPT-3 or GPT-4. And that's really exciting because they're yielding useful performance, but without requiring the kind of specialized hardware of those larger models. If you click again, here is just one small example of what this looks like in practice. These are truthfulness scores for different open models and open source models that have been tracked by the Hugging Face repository. Truthfulness in this context just means the propensity to reproduce falsehoods that are commonly found on the internet. And what we find, again, these 3 trends playing out, those solid lines there, you see we have these open base models, lowering barriers to entry, enabling thousands of developers and researchers to get in on the action. You then have these developers and researchers building thousands of specialized models for better safety or performance in particular tasks. And you can see that many of those fine-tuned models have greater performance on this benchmark and others than the original base model. And the third trend you see playing out is that smaller models, the kind of lighter colored bars there, yield extremely high performance despite being, as I say, dozens or hundreds of times smaller than the larger models. And that's really exciting because if we ultimately envisage a world where people have the kind of personalized tutor, or they're able to run these kind of education or creative or healthcare kind of tools on local devices, or we start to integrate AI into progressively more routine everyday interactions with businesses, public sector agencies, different services, we need these models to be smaller, more efficient, and to be able to run locally. So this is all really exciting. I will add that many of these open-based models are not just coming out of, Meta, for example, or us. The UAE government recently funded the most powerful open-based model. It's 180 billion parameters, Falcon 180B, and that was funded by the UAE. So there is scope here for governments to play a role in helping to establish that kind of base infrastructure from which you get a whole load of downstream development activity and innovation. Next slide. This is just a small example of the very small 3 billion parameter base model that we released last week. You can see it's the highest performing base model on a range of evaluation criteria. On the right-hand side, there's just a small snapshot of the fine-tuned version of this model. We talk about a model that's a couple of gigabytes in size when it's stored on a device, and yet it's able to perform complex tasks with a high degree of fluency, an acceptable degree of reasoning and comprehension. And that's really, really exciting. And we'll expect to see more of that over the coming months. Next slide. It's probably worth pausing here and just reflecting a little bit from our perspective on how we should think about these models in the context of existing workflows across the economy, but in particular sort of in the creative sector. From our perspective, these models and the systems and the applications that they power, they're just a tool in a creative or analytic toolkit. They're not a substitute for the creator. They're not a substitute for the analyst. They're not a substitute for the worker. They can help in a number of ways. They can help to boost productivity and just accelerate routine tasks. More importantly, they can also help folks to experiment with new concepts or new aesthetics and to accelerate, as I say, more complex activities that might have otherwise been out of reach, tasks that they might not have had the resources, the expertise, or the credentials to perform previously. I've put up here just some very diverse examples of how folks are actually using these models in practice. Again, I've given some examples at the beginning of this talk, push a button, get an image. The reality is this is a much more sophisticated tool that fits into an existing workflow. On the top left there, you can see how photographers, for example, are using models like Stable Diffusion and its derivatives to modify their existing images in really sophisticated ways. They can expand those images, they can remove portions of the image, replace them, transform that image, and do so as part of an existing workflow as a photographer, as a designer, as an architect, in very kind of functional capacities, functional use cases. On the top right, you can see just a very small example of a really exciting application for language models. I'm sure many of you will be familiar with it, but essentially helping with coding and programming, either to identify bugs in software code and sort of analyze vulnerabilities in code, or to actually propose passages of code and code that is functional, can be relatively sophisticated, and helps to support the program and really accelerate their productivity and the quality of their output. The piece at the bottom is one of my favorite. There are multiple teams around the world, including this team that we fund, MedArg, looking at how to use these image models, for example, to study new approaches to diagnosing complex medical disorders. So in this case, what they've done, and there are similar teams doing the same with Stable Diffusion and other latent diffusion models, they've taken fMRI scans from a patient, they've essentially converted them into embeddings, they've converted them into machine-readable format, and they've attempted to reconstruct a scene that had been presented to the patient undergoing the fMRI scan. And the idea being, if the diffusion model can reconstruct that image accurately, disturbances in perception could indicate that there is potentially some kind of very complex, very subtle neurological disorder, for example. And you can see here, the image that was seen by the patient and what the research teams were able to do with the model and other systems in helping to reconstruct that image with a very high level of fidelity. So again, not a creative application or not even a kind of day-to-day functional application. This is really cutting edge sort of medical and scientific applications as well. The bottom line there is that we just don't know how folks are going to use these models. We as a developer can't predict how they're going to use them, and that's why we think it's important to put these models in the hands of everyday people, researchers, businesses, organizations who can best figure out what to do with that technology. Next slide. And here, just some examples of, say, a Broadway designer, architect, lighting designer, interior designer, using these models as part of an existing workflow. Something that augments their capabilities, amplifies the kind of human intelligence, doesn't replace them, and it's not intended to be a replacement. Next slide. There is, of course, a lot, particularly in the policy space, that there's a lot of interest in how these models work, and particularly how they interact with existing frameworks like intellectual property, copyright law, and such. From our perspective, these models are just software programs that can help to generate new content. Admittedly, there's a lot of unsupervised learning, there's a lot of complex magic that goes into that process, but the bottom line is they are just software programs. They take an input, they produce an output. There's a couple of sort of attributes I want to flag here. The model learns behaviors, right? So it analyzes existing content to understand the relationship between words, concepts, and the fundamental structures or features that make up our visual or a textual system of communication. It learns this by observing patterns over vast data sets. When I say vast, Stable Diffusion was trained on 2 billion images. Many of these language models are trained on trillions of words of content. These are enormous data sets, and the size and diversity of those data sets is an important part of making these AI systems not just performant, but also making them safer and less biased. The models then apply that knowledge to help create new content. So that knowledge, that understanding of how to read and write and draw is generalizable, which means the model can develop new content or support tasks that didn't necessarily appear anywhere in the training data. And in many cases, it will apply that knowledge imperfectly. So if you see on the right there, these image models notoriously struggle to generate accurate images of hands. You can see in this case, all of the hands have the wrong number of fingers, and in one case, the hand is missing an arm. And that's because the model isn't searching a database of images of arms. It's not stitching together existing images. It has learned that a hand typically is associated with these kind of fundamental local structures, and it's applied that knowledge imperfectly to help generate these images. At a great point, there is, in this case, no women's hands. If you type CEO, doctor into many of these models, we continue to make progress on bias, but there are still biases there that are amplified from the training data that is fundamentally drawn from the internet and amplifies the biases of the internet. So that's an ongoing challenge as well. And the final point is that the model is a tool, and it operates in the direction of a person, right? Like the human is in the loop. The user provides creative direction through prompts or reference images or other settings. And that user ultimately determines how the content is shared or represented to others downstream. The bottom line there is that, from our perspective, we take the principled view that this kind of training, this kind of development is acceptable, transformative, and beneficial use of content. It's protected by fair use doctrine in the US. And, as I say, that size and diversity of those data sets is an important part of how we address safety and bias and other kinds of undesirable behaviors. That said, we are keenly sensitive to emerging concerns from creators, and I'll talk a little bit about some of the steps we're taking to address those. Whatever we choose to do from a policy perspective on this fundamental question of how these models are developed, it's important that we preserve the culture of open access, open sharing that help to make these breakthroughs possible in the first place, but helps to make them safer, less biased, and more effective. Next slide. This is just something that occurred to me the other day, and a good example of what I was just talking about, challenges and limitations I was talking about before. This is a generated image of the Pentagon in Washington. This Pentagon is actually a hexagon. And again, it's because the model understands local features. It can assemble local features, doesn't necessarily understand global features, and it isn't stitching together existing works or existing images or existing text to produce that new output. Next slide. I'll breeze through some of this because I want to get to the Q&A. But just bottom line here is that I think generative AI, to the extent that it is a separate category or can be described as one, it can feel like a new policy challenge, right? These models are adaptable. They can be deployed for a wide range of tasks. They're credible. The content is compelling and believable, and folks can rely on that content, not knowing that it's AI generated and has all the limitations of AI generated content. And it's scalable. And so it produces content at speed and scale, and that transforms the economics of content production in ways that are generally extremely beneficial and in some ways potentially challenging. But I think I'd really like to sort of anchor us in this view that actually generative AI represents a kind of old set of problems that we are familiar with in the policy space, we're familiar with in the research world as well. And those are, and I'm sure I'm sort of preaching to the converted here, but transparency. We don't necessarily understand the rules that determine the model behavior. We don't understand how they arrive at the output from the input. And that's going to matter as we start to integrate this into sensitive contexts like healthcare, law, public administration, education, finance. The second is reliability, right? Their understanding of the world is limited to the relationships that they pick up in the training data. They have a very poor understanding of other rules-based systems that govern our world, science, for one, social norms. And they're just one part of the supply chain. And different entities can contribute different capabilities to the final AI system. So ChatGPT is not a model, it is a system comprised of a model plus a whole bunch of other applications, an API, and a bunch of other things. And so the challenge there is that responsibility for the deployment and the performance and the risk of the final AI system can be diffused across a number of different actors and potentially result in a failure of oversight or a failure of accountability. Next slide. I won't dwell on this, but this is just a kind of visual illustration of that final problem, which I would describe as kind of core to the policy challenge in AI at the moment, which is that there isn't just one, one gatekeeper or one choke point. There are many actors. These models are being deployed for a range of different applications in many different kinds of environments. And there are different stakeholders kind of implicated all the way through that supply chain. And they have very different relationships with one another. They have made different representations about the suitability of the components. They may or may not have financial interests. And so it is as I say, a more diverse ecosystem, a more diverse supply chain than I think folks in government sometimes realize. It's one thing to be a vertically integrated company and to just own that entire tech stack end to end. But the reality is that a large part of AI deployment and development is going to involve a ton of different actors and stakeholders who all contribute something different to the final AI system and the final AI outputs. Next slide. If you were to just focus on models, models come in all shapes and sizes. We really don't, government authorities, the research community doesn't have a bright line rule about how the size of the model, the context window, its ability to process sort of larger amounts of sort of background information, the quality of the data, the compute resources available for training and for running the model, the extent to which it's been fine-tuned, the extent to which it's being integrated with other systems. Can it execute financial transactions? Can it publish something to social media? There isn't a bright line rule determining the risk of these models because there are all of these variables. And so we really urge policymakers not to sort of over-focus on the model. It's just one part of the AI supply chain. And it's important that we take all of those different parts of the supply chain into account. Next slide. So what that means from a harm minimization risk management perspective is that there are no silver bullets. Again, it's one thing to say, oh, hey, we own the tech stack, we can just kind of turn everything off through the API. It's another thing in the open source world, because you don't have those silver bullets. But what we do have are layers of mitigations for emerging risks. Some of these before we release the model, some of them as we're releasing the model, some of them after we've released the model, mitigations that apply to the wider information ecosystem. If you flick one more, Alison. For example, in the data sets, we filter these data sets for unsafe content, making it harder for the model to produce unsafe content. We remove content that is being opted out by creators. We've received 160 million opt-out requests to date, and we are honoring those opt-out requests in upcoming training for our image models. We make sure, as far as possible, that these data sets that we're drawing on have sourced the data from appropriate sources. The 3 billion model we announced last week does not include some of the more controversial sources like Books 3 that have been a source of contention with the creative community. And we're also addressing issues like overfitting bias. If a model has only ever seen pictures of a sunset, it might think the sky is always orange, right? And variations of that problem can be hugely challenging as we deploy these models in different environments. So we filter, deduplicate the data set to control for those kind of risks as well. Next slide. We move down the tech stack. Once the model has been sort of initially trained, we then fine-tune it. Fine-tuning yields, as I say, a huge change in performance. You can see just some examples here of a base model and what happens when you do a little bit of fine-tuning on that model. It goes from saying, yes, drink bleach to prevent coronavirus to, no, that's unsafe, go and talk to your doctor. So fine-tuning is a really important part of mitigation, and we can fine-tune before we release, ultimately making it harder for reckless or bad actors to introduce bad behaviors back into a model. Next slide. We rigorously evaluate our models before they go out and are working to develop, again, more robust protocols and standards for what that looks like. We took part in a recent White House sponsored event at DEF CON, where folks over about 165,000 messages attempted to elicit bad behavior from these models. And that was a really great sort of prototype example of what independent evaluation and red teaming might look like at scale, and we're continuing to explore protocols for those kind of independent evaluations as well. Next slide. We disclose the limitation, the performance of our models. Hugging Face, Elutha, and others, GitHub have done some great work on helping to standardize the disclosure of these these risks, these limitations. And we want to make these more robust over time and make sure they're understood by downstream developers before they use a model and integrate it in perhaps an unsuitable context. Next slide. We have ethical use licensing for our sort of more powerful models, or models that potentially may be misused in more problematic ways. Next slide. We filter content that is produced on our compute platform. So we have a huge amount of compute that we make available, and we can filter both the prompts going into the model as well as the outputs coming out of the model. There's a kind of another backstop, another line of defense. Next slide. We've introduced watermarking content metadata for content produced through our API platform. This kind of serves two functions. One is that it helps to protect the kind of integrity of the human-generated content marketplace. It makes it easier for folks to understand if this is AI generated or not. But the other, probably more important purpose it serves is providing another signal that downstream platforms can use, the social media platforms can use to determine if something is AI generated or not before amplifying it online. Next slide. We have a huge number of laws, technology neutral laws that govern bad conduct, whether it's with AI or not. And I think what we'd love to do is to see these laws fortified where they need to be fortified. So for example, certain states are introducing more specific deepfake legislation to stop the kind of Tom Hanks scam that we've seen over the past week. And we know that the FEC and a number of senators are looking at rulemakings or legislation that would make it clearer that AI-generated content like this, designed to mislead during an election period, is unlawful. Next slide. And just a final point there, I think it's important that these laws identify unlawful conduct with precision, but we also have a mind to protecting legitimate expression, parody, or creation via AI tools. I think sometimes there's a bit of a tendency to overreach with some of the concern around disinformation, misinformation. And we just want to make sure that there isn't a chilling effect on artists, creators, developers who are using these tools in totally legitimate and often very incremental ways, and that they aren't caught up in some kind of very broad intervention around disinformation, misinformation. Next slide. The final piece is, AI will be a shield, not just a sword, right? In the same way that software can be used to make viruses, we then have an antivirus industry. We believe the same pattern will play out in AI. AI is already being used for deepfake detection, content moderation, vulnerability detection, software patches, intelligence analysis. The CIA is building its own open source chatbot. We think that the investment and the energy flowing into the defensive applications of AI is really going to help to mitigate a lot of these kind of future-looking risks, and we'll continue to support those efforts. Next slide. Okay, a lot here I don't need to boil the ocean on, but I think, I talk a lot with folks on the Hill, in the White House, in London, Brussels, Singapore, and elsewhere about future policy. And I think at a very high level, all of these jurisdictions are taking a slightly different approach. It's really important that whatever we choose to do, whether it's specific legislative intervention or whether it's a broad legislative package like the EU's AI Act, we mitigate risk while also promoting and accounting for diversity in this ecosystem, right? We have open source, we have closed source, we have big players, small players, global, local developers, and they're all contributing to making AI more transparent, more competitive, and improving access to foundational technology. So whatever we choose to do from a policy standpoint, we have to account for that diversity, account for the complexity in the supply chain, the different risks that an AI model will generate in different kinds of environments, and the different mitigations that we have available from technical to legal, voluntary to mandatory. From our perspective, I think short term, it would be really important, I think, to see greater precision in how governments are assessing different kind of risks. There's kind of product safety risks. You use your AI model, you integrate it into a healthcare chatbot. How do you evaluate for safety and risk in that context? There's the kind of basket of risks around intentional misuse, everything from misinformation through to abuse and fraud and a whole stream of other kinds of harms. And then there's a kind of question around emergent capabilities. Will these larger models have properties that we don't understand in advance and potentially pose a serious systemic threat to the community? But these risks all require a different response. You can't boil the ocean in one piece of legislation and deal with all of that at the same time. And I fear that that is, to some extent, what's happening in some of these conversations. So from a policy perspective, we really urge governments to think through 2 or 3 sort of high priority points. One is do a gap analysis of where horizontal law and horizontal regulation fall short. What we want to see is standardized disclosure practices between upstream developers and downstream developers of AI systems. We want to see robust privacy obligations around the handling of user data, particularly where the user data is used to fine-tune or improve an AI model in ways that could be potentially exploitative. We want to see technology neutral rules governing conduct, again, conduct to defraud or abuse or mislead another person, and clear principles governing accountability, taking into account all of the variation in that supply chain. Now, to some extent, existing law does this already, but what we haven't really seen in many jurisdictions is a gap analysis of where it falls short. We need to do that as a matter of priority. What then needs to happen is we need to see agencies, DOL, FDA, DOT, SEC, coming out with performance requirements so that as folks start to integrate these models into more sensitive applications, there are clear guidelines in place around minimum reliability, interpretability, explainability, the assurance that you need to show the agency before you can deploy into this kind of sensitive context. And finally, big piece is around accelerating the investment, public and private investment in research, evaluation, and testing resources to support a vibrant assurance ecosystem. If we don't have a vibrant assurance ecosystem, then it doesn't matter what government puts in place in terms of guidelines and rules, we won't be able to measure for them. Downstream developers won't be able to measure for them. And so we want to see sort of accelerated investment there, whether it's through NIST or the National AI Research Resource, and especially for emerging capabilities. If folks want to see a world where AI models have to be licensed by the government prior to being developed or released, there's huge risk with that regulatory structure, huge risk that we kind of entrench a statutory duopoly. And I think it's really important that before we put the horse before the cart, we understand what we're measuring for. What kind of risks are we looking for? Do we have robust evaluation frameworks for those kind of serious risks? And if it was the case that a model exhibited evidence of dangerous capabilities like that, I don't think anyone would want to develop or release that model publicly. But we need those frameworks beforehand, and they're very, very underdeveloped. I think there's one more slide, Wilson. I don't need to go through this, but again, just to reiterate, the different jurisdictions are taking a different approach. And the final point, just to kind of close off the final slide, Alison, I think there's a few misunderstandings in the public policy world in government that are helpful to clarify, right? One is that the AI model is not the AI application. The model can be used in a bunch of different ways, but the risk really depends on how it's used in a particular environment. The second is that automation of a task doesn't mean autonomy. There's always a human in the loop. And that means there's a human who's amenable to enforcement, but it also means that you need to have accountability across that supply chain. It's not enough to sort of treat these models or treat these tools as if they're kind of an independent agent. We need to make sure that the developers and the deployers all have a role to play in safety and assurance. The third is that I think we will continue to see a really interesting transition away from design analysis. In other words, understand exactly sort of how the nuts and bolts of the system come together and move instead to performance-based regulation. When you say like what we care about, we don't really know everything about how this works under the hood, but what we need to see is a certain level of performance, reliability, robustness, etc. And I think some regulators are moving in that direction already. I think others will need resourcing and mandates to sort of catch up, but I think that's going to be a really interesting regulatory trend. The fourth piece is that, again, to reiterate one of my earlier comments, AI regulation, generative AI regulation is really just a subset of algorithmic regulation that is long overdue. And there's a lot of work that was already happening. AI is helping to accelerate that. That's great, but we shouldn't sort of try to carve AI out as if it's something new. There have been transparency, reliability, assurance challenges that predated generative AI, and we never quite resolved them. And the final point, as I say, grassroots innovation in open models is helping to make AI safer, more useful, more accessible. Let's see more of it, and ultimately have a robust regulatory environment that mitigates these risks, but also promotes and accounts for and actively supports that diversity. So I've blown well over my allotted time, I think. But hopefully that gave you a sense for how we think about these different issues. And yeah, as I say, happy to take questions and also just continue the conversation. Pretty easy. I'm not sure how you wanted to take the questions, Alison.
First of all, I'll say thank you very much. This has been hugely informative. I see we already have people raising hands. But before we go into those questions, I have one for you. You have worked with different companies, jurisdictions, and so forth. How should academia develop policies or framework that will still allow for the creativity and use of this technology and still not be plagued by laziness or plagiarism? What kind of policy or what kind of approaches should academia be taking in developing these frameworks?
Yeah, look, it's a great question. I think generally non-commercial development and application of this tech is generally less controversial and less contentious on some of those areas. And so we know that no one in the creative community is really out there to sort of go after academic applications for models, for example, or academic development. But look, I think it behooves everyone in the space, whether it's kind of formal institutional academia or whether it's kind of grassroots researchers and developers, to have kind of frameworks in place for thinking about how to, appropriate to their level of sophistication and size, how to develop and deploy these tools in a way that's consistent with their principles. I think we've seen some interesting initiatives. We've obviously seen huge initiatives like the EU Act, which actually supplies some very kind of baseline expectations that are manageable, realistic, and not too onerous. And we've seen, in the US, the NIST risk management framework and other things. These all kind of provide a baseline how to build up, guardrails and internal policies around the development of these capabilities. But as I say, look, I think all of this is fairly underdeveloped, and I think everyone, whether it's commercial developer, downstream deployer, academic or research community, there's still a lot of work to be done on thinking through how do we actually implement all of these lovely principles that we talk about in white papers, and implement it in something that is actionable and applies to day-to-day work. I think there's a bit of a gap there still.
Thank you. I see Swati would like to have a question.
Yes, thank you so much. Thank you, Ben. This was an excellent presentation. You briefly touched upon about this question in the presentation about how do we tag or stop the spread of misinformation that was generated using AI. You talked about the concept of watermark, but I just wanted to know if there are other ways we can detect misinformation before this misinformation spreads or is widespread.
Yeah, look, it's a great point. I'd say actually, as a kind of preliminary point, I'd say the challenge with misinformation and disinformation was never really that it existed. It was that it was amplified, and now it's easier to produce, and therefore you see more of it. And so our intent with watermarking and metadata and other mitigations like that is not necessarily to have a kind of immutable tag or flag that follows the content wherever it goes online. It's actually very difficult to implement. A lot of this stuff can be obscured or split from the content by a bad actor. The intent's really to help the kind of the Metas and the Googles of the world just have a few more signals that they can use as they build up progressively more sophisticated content recommendation systems. And so you can imagine a world where it's a week before the election, Instagram sees an image that hasn't appeared anywhere else on the platform, doesn't appear on the internet, from an unverified account that's 2 days old, showing a candidate having an affair. They use deepfake classifiers to determine that there are some indicia that this may be a deepfake image. They can't see if the metadata confirms that it was AI generated. I think they'll get to a world where instead of amplifying this stuff by default, they'll verify it by default, and that will go a long way to stopping the spread of that information, which was particularly problematic in the last election. And in terms of other ways to kind of detect this stuff, as I say, I think deepfake detection is going to be a huge area of focus. As I say, I showed you the images of the hands, right? That in some ways there are some very obvious indicators when this is a deepfake. You look at the photo of Tom Hanks, he looks like he's 20 years younger. But we will see very sophisticated tools coming out with the big platforms that help to make that detection process more effective. And that's going to be a huge part of the mitigation strategy as well, I think. All of this is a bit harder in the language context, but I think the language context is less, it has less of the urgency and the immediacy of image and voice. I think if you think about the kind of the most persuasive medium is going to be voice, as we've already seen with some of the kind of fraud campaigns that have been running globally. And so we need ways of not only detecting voice cloned content, but also have in place clear legal frameworks that determine how voice cloned content can be used, and ideally have watermarks and metadata that we can kind of bake into that content to, again, just provide an additional signal to downstream platforms.
Thank you. I think we can have one more question or two max. Sharon, would you like to have your question?
Can you hear me all right?
Yes.
Yeah, okay, thank you. Actually, I have two questions now. One was, which country or region do you think is really making the most progress toward the vision that you presented here? And my second question is, it seems as if the overall scheme puts a lot of responsibility on platforms. To what extent are companies like yours working directly with platform companies, and are they responsive?
Yeah, great questions. So the second one first, yes, we are. We've made it clear to the White House, for example. We've made it clear to Google and Meta. But here's what we think we're able to do in terms of tagging data, for example. We'd love to see you kind of incorporate this into your own content recommendation, content detection processes. The metadata standard that we use was spearheaded by Adobe. And so it's something that they have really pushed as well with broad consensus across industry, but we're one of the first to actually implement it. So it's kind of early days to see how the big platforms respond, but we certainly want to do what we can to provide those signals. In terms of the first question, it's really interesting because the different jurisdictions are kind of tackling different problems, and there isn't a lot of joined up thinking in some ways. The US, the White House AI commitments that we and a few other firms have signed up to really are directed towards serious risk. Can you evaluate these models for their capacity to assist in bioterrorism, for example? At the legislative level, there's kind of a scattered, there's some efforts that are about tackling specific harms, use of AI during an election campaign, use of AI in consequential or critical decision making. And then at the other end of the spectrum, there are these kind of very, very broad proposals to, introduce a license framework for companies that want to develop AI models, which we have fairly strong thoughts about. But yeah, again, even within the US, we're seeing folks tackling very different kind of parts of the puzzle. The EU has kind of taken this horizontal legislative approach. They want their AI Act. It's the draft of the three institutions is about 300 pages long. It's a big act. But it is meant to be risk-based. The requirements on different actors in the supply chain will vary based on the way in which the system is deployed, the purpose for which it's deployed, etc. And then somewhere like the UK, has actually taken a fairly conservative approach in some way and said, look, we're just going to leave it to our regulators, our financial regulators, information regulators, healthcare regulators, to figure out what safe and fair means in their particular context. I think that's the right approach. We just haven't seen clarity around, like, are they going to resource it properly? Is there a mandate to those agencies? And the government, meanwhile, is doing a lot of work to kind of invest in frontier AI safety, which is, GPT-4, DeepMind. And that's great, but we need to see safety behind the frontier as well, because the behind the frontier models and systems are the ones that are going to be powering most of the economy. So again, long way of saying that they're all tackling different issues, but I think if you kind of pick and choose from different ones, you end up with, a fairly coherent legislative and regulatory response. I just don't think we're seeing it all in one jurisdiction at the moment.
Hey, Deb, can you ask him my question from early on? Like, like why are we not putting quotes and sources? I think Bard will do it if asked, but I thought Google wanted to do no harm. So why would they want to open themselves up to plagiarism claims and things like that?
So you mean in terms of, if someone searches on Bard, are they getting a citation for the source that was used?
Yeah, I don't think any are unless you ask for it, and I'm not sure all will give it to you or will do it properly.
There's a big effort across, and for from our perspective, we're trying to do it as well. But we know that the other firms are really looking at retrieval augmented generation and other techniques. So in other words, you kind of use the transformer-based language model to provide a kind of fluent, coherent, natural language response, but the actual information you retrieve in a kind of potentially a more rules-based way, a way that doesn't engage the kind of language model component. So the idea being, you go to Bard or you go to Bing Chat and you type in, I've got COVID, what do I do? And instead of just kind of sort of assimilating random facts or hallucinating facts from its kind of language model training, it will go back out there onto the web, have some way of determining what counts as a credible source or what doesn't, and then it will then use the language model to digest and summarize that source, present it, and then present it with a hyperlink and a source as well. So I've seen Bard and Bing at different times have both had kind of citation and sourcing. I think it's a bit hit or miss in terms of reliability still. And the other challenge, which no one's really talking about publicly, is what happens when no one's clicking through hyperlinks anymore. Like, what happens to the ad economy, which sustains a lot of websites? I think that's going to be an interesting one. If everyone's going to a chatbot to get all of their kind of internet search advice, recommendations, information, there's a fundamental sea change in the way that value flows around the digital economy there. And I think it'll be interesting to see sort of how that unfolds.
Sorry to interject here, but I think we're at about 1:07 now. I just wanted to wrap up. Thank you all so much for this really thoughtful and thought-provoking Q&A. Thank you so much to our speaker, Ben Brooks. And we hope you all will stay in touch with Good Systems and join us at our next speaker series events. Thanks again.
Thanks all.
Thanks, Ben.
Thank you.